Hey all, this is Derek, and this is section 1.4, Algebra and Composition with Functions. And so we're going to look at a couple of different versions of this with graphs and then with equations coming up. And the idea is we can use function notation to kind of shortcut directions. So this down here, f plus g, evaluated at 2 is what this would be. This is the same thing as f of 2 plus g of 2. So those two notations mean the exact same thing. This over here means f evaluated at -4 times g evaluated at -4. Probably don't need that second set of parentheses there. Maybe a dot would have been cleaner. But hopefully you can see what I mean. So it's basically we're just going to figure out what the two values are and then add them together, multiply or divide or subtract. So this time we're doing it from a graph. So we're going to look for f of 2, which looks like it is 3, plus g of 2, and this one's g, and so g of 2 is -2, and so it looks like that one would be 1. F minus g evaluated at 0, so f at 0 was 3 again, g at 0 is -2 again, but this time we have minus and negative, so that's going to make that a plus, and so that will equal 5. Over here we had f evaluated at -4, which is 0, so that pretty much means this is going to come out to 0 because of the multiply. But just to finish that up, g is also 0, so that one makes that 0. And then f evaluated at 1 is 3, and g evaluated at 1 is -2. So then this is going to be the same idea, except now we have equations instead of graphs. So what we can do this like formatted a bunch of different ways. We could just go and calculate f of 2 or -2 and then calculate g of -2 and then add those numbers together. I could write all this out with the -2 plugged into all this plus all that. That would work also. And then I can also do where I do the algebra first and I actually add these. So if let me write this out just to make it bigger. So if I have that, I can plug the -2 in right now and I would get an answer. Or I can collect my terms first and plug -2 in and I will get the exact same answer. So I'm going to do that because when we're adding, subtracting, to me that always feels easier to do the algebra and kind of get it to smaller and then do the evaluate. So this will be plus 6x minus 2 up 3 is plus 1. So that's f plus g. And now if I evaluate that at -2, so I'm just going to do an equals from here because I didn't leave myself very good room. So there we are, just putting -2 in for everything. So this will be 4 minus 12 plus 1, or 5 minus 12, so that should be -7. I will do the same thing over here. This time it's a subtract. And again, I could plug in the value 4 right now, or I could collect terms, either way. When we get down to the multiply and divide, to me it's much easier to just plug it in directly. For add, subtract, I tend to like to collect first, but it's fairly arbitrary, whichever one seems the easiest way to go. So x squared 5x minus x will leave us 4x, minus 2 minus 3 should be minus 5. And then we're evaluating this at 4. So 4 squared plus 4 times 4 minus 5. So that is 16 minus 5, so that should be 27. F times g evaluated at 0. So here you can just see if I put in 0, x squared 5x drops out, so all that's going to be left is 2. And here if I put in 0, 0 plus 3 is going to be 3. So there's definitely no reason to do a big giant FOIL and then put in the 0. It's much easier just to plug it in directly this time. And I get -6. And then here, -3 plugged in will get us -3 squared plus 5 times -3 minus 2. And then over, -3 plus 3. Okay, so this is going to make some number that I don't really care about. because this makes 0, so that is a does not exist or undefined because of the division by 0. And then this is doing the exact same thing but with algebra. So f plus g would be x squared plus 5 plus x minus 6, and then we're just simplifying from there. So x squared plus x, and then 5 minus 6 would be minus 1. F minus g, so here we'd have x squared plus 5 minus, and then really important to get the parentheses around the second term anytime we're subtracting, and that's so that negative gets distributed through. So x squared plus 5 minus x minus a negative 6, and that's the sign that ends up going wrong, is right there. And so then this will be x squared minus x, and it looks like plus 11. F times g, so that's just going to be a FOIL. So x squared times x, x cubed, x squared times negative 6, negative 6x squared, 5 times x, 5x, and 5 times negative 6, so negative 30. And then just double check, there's no like terms, so that's as good as that's going to get. And then d is great. The worst thing about it is typing it. X squared plus 5, that's f over g, x minus 6. I can't factor, which means I can't cancel. What I mean by that is, think about if I have something like 10 over 2, I can write that as 10 times 5 over 2, and because I can factor that, I'm able to cancel. Here, nothing factors out of these or here, which means I don't have like terms and I can't reduce. Okay, so the rest of this video is going to be about composition of functions or composite functions. So evaluating a composite function, we got a couple of notations going here. I'm going to write this a little bit bigger. There's this thing that kind of looks like a degree symbol, and that means f composite g, or the composition of f and g. The other way, which is kind of the one I prefer to write it, is like this. And this shows that f is being evaluated at g of x. So g of x is going to do something. It's going to either just be a function or it's going to make a value. And then that function or value is going to go into f, and then f will be evaluated at that. So it's like it's a function within a function is essentially what composition is. So the steps for this, if we're evaluating, we're going to take the inside function, in this example g of x, figure out what that is. You know, if they told us g of 3, we'd plug in 3 and figure out what g of 3 is. And then whatever that output is, that's going to go into f, that's step 2, and then we'll calculate the final result. For when we do the composition of the actual functions, basically with this, whatever g of x is, it becomes the new x. You take that function and put it in all the x's for f. It'll make more sense when I show it with an example. Okay, for number 4, I just started it, but I didn't write down a sign, and that kind of messed things up, so I'm going to redo it here. What we're going to do is we're going to find g of 2 first. And so what I had written out here was I'm looking for g of 2. This is my function labeled g, so I come over here to 2, and then that makes negative 2, and it helps when I write down that negative sign. So then, since g of 2 is negative 2, I'm going to plug that into there for that g of 2, and then that tells me I'm finding f of negative 2. So now I can come over here, and when x is negative 2, it looks like that result is 2. For b, we're finding f of negative 3, that's our inside function. So f of negative 3 would be 1, and then that tells us since f of negative 3 is 1, I can make this whole thing right here g of 1, because f of negative 3 is 1. So we come over here, when g is 1, it looks like the output with that is negative 2. Similarly, f of 4 is negative 1. So now we're finding g of negative 1, that goes into the outside function, and it looks like that is 0. And then g of 0 is negative 2, and then f of negative 2 is 2. Question 5, same idea, but with a table. So g of 2, And the way this is organized, so here's our x column, and then if we're looking at f of x will be this column, g of x will be this column. So here we're looking when x is 2, g of x is 5. So then that tells us to find f of 5 because it goes into our outside function. So come down here to x, and when x is 5, f is also 5. B, we're finding f of 7 first. So 7 looks like that makes a 2. That goes into g. So g of 2 would be 5. F of 4. So we come down here for 4, and then f is 3. That goes into the outside functions. We're finding g of 3. When x is 3, g is 7. And then g of 1 is 3. And then f of 3 would be 1. Okay, number 6, we're doing the same basic thing, but now we're doing this with equations instead of tables or graphs. So we're asked to find f of g of -2, so we're going to do g of -2 first. We come over to our function, label g, and then we evaluate it at -2. So 3, and then -2 in for the x plus 1, and g of -2 is -6 plus 1 makes -5. And then -5 is going to go in for g of -2 again. So that means we're finding f of -5. And now I just grind that through, and then that'll be our answer. So -5 squared minus 3, -5 plus 6. 25 plus 15 plus 6. So 25, 35, 46. Same thing here, just written in reverse. So this time we're asked to find f of 1 first, g of f of 1. So f of 1 would be 1 squared minus 3 times 1 plus 6. So f of 1 would be 1 plus 6, 7 minus 3, 4. And then that would let us do g of 4 next. And that'll be 3 times 4 plus 1, and 12 and 1 for 13. Okay, so now we're doing composition, but rather than evaluate it at a particular value, we're just doing a composition of two functions. So we'll just end up with a new function. So I always think of this as f eats g. So g is going to go in for all of those x's in f. If you think about what you would do, if you pretend for a second this said f of 5, you'd go like 5 squared minus 3 times 5. So all the same places you're putting this 5, now you're going to put g of x. So it's like we're evaluating f at x plus 4, essentially, which is that g of x. So that would look like x plus 4, and then squared, because that's our new x, minus 3, and then x plus 4. So you see how that's just being evaluated at that function. And then from there, we just got to clean that up. So right here, I'm going to FOIL this out, and I am using a plus b squared equals a squared plus 2ab plus b squared to do this. If this is your last math class ever, you can write them side by side, FOIL it, and do the steps. If you got a lot more math and you didn't pick this up in your intermediate algebra class, learn it now, because it's very, very handy for doing quick FOILs without having to rewrite a bunch of stuff. So FOILing this, I would get a squared, so in this case x times x would be the x squared. 2 times a times b, the a and the b are the x and the 4, so 2 times 4 would be 8 times x. And then b squared, 4 times 4 is 16. And so if you wrote it this way and did all your FOIL steps, you end up at the same spot. But if I do this at full speed now, all I'm doing to do it is x times x, x squared, 4 times x, double it, that makes 8x, 4 times 4, 16. So I can write the answer faster than you could write out the FOIL to do it. So if you got a lot more math to go, make sure you know that little time saver right there. And then we'll minus 3x And minus 3 times 4, 4. Oops. Making up signs. 12. And then we could do a little bit of simplifying. So x squared, 8x minus 3x plus 5x. 16 minus 12 plus 4. And then for part B, G is going to eat F. So everywhere there's an X in G, it's going to be replaced by F. So for this one, we are finding G of x squared minus 3x. X squared minus 3x, and then just with a plus 4 on the end. And then this last one is basically just doing the same thing, except it's giving the other notation. So this F composite G is the exact same thing as F of G of X. So in this case, we're finding F of 3x squared minus 4x. And so that will equal basically this plugged in for that x right there. So 2 times 3x squared minus 4x. And then that plus 5 on the end. And then I just need to clean this up a little. So that would go 6x squared minus 8x and plus 5.